Davi is going to talk to us about barbarians at the gate, data protection at massive scale. I'm going to turn the lights down, but you have to stay away.
Thank you. How many people have read Babar? Quite a few people. How many people are running Hadoop today? Have a Hadoop cluster? How many people don't know what MapReduce is or how it works? Anybody? Nobody wants to admit they don't know how MapReduce works? Why should I trust you? All right, my name's Davi Ottenheimer, Senior Director of Trust. People ask me how I got that title, and it's, I guess, because I used to be the Manager of Respect, and then I got promoted. No, but really this presentation breaks down into why you should trust big data. And I'm really happy to be presenting today, especially after Dan Geer's keynote, because he covered a lot of the topics I like to dig into. So hopefully it's a good continuation. I have 20 years of experience in Infosec, and my background really is in these 4 areas: in audits, in forensics. I did a lot of product work with different companies, including EMC now, obviously. I did operations work where I ran global teams that did security. And so after quite a bit of time in the industry, I wrote a book called Securing the Virtual Environment, and it's actually for sale. And then I'm writing a book now called Securing Big Data. The idea of the new book was to be like the old book. The old book was hands-on. You want to get into cloud, you want to trust cloud, do these things, and you can have a safe, trusted cloud. But when I started writing the new book, there weren't really things you could do, and that kind of scared me. So I started changing the title, and I changed the book. And it's been a lot more work. If you want to find out why you shouldn't write a book, come see me afterwards, I'll tell you. And the idea really is that I want to help people secure big data, but we're not there yet. So before I get too far into it, though, let me also point out that my background was in anthropology. My first presentation was actually in 1984, so it's 30 years ago. I was a little kid. My parents forced me into labor and forced me to give a presentation at a conference. It was about a secret language we discovered in Africa. And then after that, I went into political science, tried to get away from technical stuff that my family did, and I studied essentially the ethics of intervention, so why you'd go in and take over someplace. Comes back now today, we see a lot of people asking why you would take over a command and control server. This is basically what I studied, but before it was an issue in the internet. And then finally I got my master's degree in liberation strategy, so why you'd go into some place, take it over, such as the no IP case you saw recently with Microsoft. So that was my background, but now what I work on is trusted IT. And the 3 things I like to emphasize in trust are that you need transparency, you need relevance, and you need resilience. And I hope that's sort of self-evident. I tried to make this so that it's easy to understand and grasp in terms of technology, because transparency, you wouldn't move into a big data environment unless you really could understand what's going on inside of it. That was the heart of Dan Geer's talk, really. If I can understand it, I can really work on it. I'll start to trust it more. The relevance is, of course, if we have these tools from the past and we try to use it in the future and they're not relevant, they don't work, right? People say all the time, this is cloud, this isn't old IT, this isn't traditional IT. So we need relevance to really believe things are going to do the right stuff. And then finally, resilience. If it goes down, people get upset. That's perhaps the one that comes up the most often. When Hadoop clusters fail, when they're not resilient, people get mad because they want performance, performance, performance. So just a little snapshot into some of the stuff I'm working on right now. I'm trying to get the United Nations War Crimes Commission, which is bringing my career full circle. I started out in the sort of international human relations and history and study, and now I'm working on these huge data archives of war crimes that I'm trying to put into a digital archive, and then we'll be able to mine them. And this will fundamentally transform and change the way that we prosecute war crimes. One of the strange things about it is that we have almost 2,000 trials that have been sealed. They've been secret since the 1948 time period. And we've been basing all of our international war crimes on just a few trials because no one knew that they existed. So we're going back in time and trying to understand better what to do in the future and how to prosecute people better. So let me jump right into the technology then. We actually have so many definitions of big data. They tend to boil down to 3 V's. Has anyone not heard of the 3 V's of big data? So I've transformed them a little bit to the 4 R's. The V's used to be volume, variety, and velocity. About 2 years ago, I started adding in vulnerability. And my argument there was that when you get so much data that you can re-identify people, it becomes a problem. And that makes it fundamentally different than other data sets. So for example, I've run into a case where if the zip code is sensitive because it can identify you and people get rid of it, people are sneaky and they keep the doctor name in the records or some reference. Because if they can look up your doctor name, it's probably in a zip code. And so once you start amassing more and more data, suddenly the relevance of data, connections to each other, the link basically, makes it harder and harder to make it safe. So I've changed it basically to the 4 R's because the range of data, the real time or the RIME, the raw, and the re-identification of it makes it, I think, pretty interesting to try to secure. So anybody recognize this? Anybody know what this is a picture of? Mayflies, that's correct. So there are so many examples of where we have big data. You know, this is coming in at real time. We're looking at it. It's a radar system that's telling us the weather, but it's not the weather. It's something completely different. And this shocks people. Wow, we're looking at insects. They're showing up on weather radar. So maybe our information isn't perfect. Here's another example. I did a little searching on how people behave when they use Twitter, and it basically boils down to if you have an iOS device, you might be on a small craft, maybe a yacht, moving around the bay in San Francisco. But if you have Android, it looks like you take the ferry every day to work. So poor people have Android, those wealthy yacht people have, or maybe they're fishermen, hard to say. Here's another test though. This is the BlackBerry community in San Francisco. This isn't real time, obviously, it's a snapshot, but can anyone tell me maybe what that concentration of BlackBerry users represents? Workers? Nope. Government office? That was my first guess, honestly. I thought that's where the government office would be, but it's not, because I looked at the map and that's not where the government office. There's a new federal building and I thought that was it. It's actually where the Apple store is. All right, but not to make too much fun of people. So really what it comes down to is if you can store huge amounts of data and you can do analysis of it, you're winning the race, right? That's what everyone's talking about these days. You will be more successful in business in the same way that in 1994 people were saying if you get on the internet, you will win the race. We're now saying if you get onto big data, you will win the race. It's the future way of handling data. You're going to store everything, you're going to analyze anything you can, and that's going to make you successful in building the thing that needs to be built for the right audience, right? And there's a little tiny piece in here that I find really interesting. If you see in the middle, people call this sometimes the rear view mirror. Well, not many people realize the rear view mirror was invented for racing. So here's this guy, it's the first Indy 500 in 1911, and he shows up with this crazy car that's aerodynamic, first aerodynamic car to be raced, and he shows up with a rear view mirror and no passenger. Because before this, they always were required to have a mechanic on board, and that person would look backwards and try to tell them someone's going to try to pass you. So this guy puts in this mirror, he's faster, he's got less windage, and he wins the race. I think that was his last race, actually. So this is an interesting model. If we use rear view mirrors, we might be able to build security in the same sense that helps people go faster, right? I think that's a really good model. But another way of looking at it is, my computer is complaining. If we look at the rear view mirror as the start of sort of the change in technology in the race cars, we can look at 1956 as kind of the end when seatbelts were finally brought into race cars. And all this stuff in between, these interesting technologies, you know, these are like, if we look at it in a big data context, maybe we can make rear view mirrors. But when are we going to get to the seatbelt? When we're actually containing data, when we're preventing it from being lost or being destroyed. So I try to keep this in mind when I work with people, when I consult with people about how to make their environment safe. Am I helping them build a rear view mirror, or am I helping them build a seatbelt? And keep in mind, it took 45 years. I don't know what it will take us now, but we're definitely not yet at the seatbelt phase. We're just building rear view mirrors, in my estimation. It's also interesting to notice that only 2 years after race cars adopted the seatbelt, passenger cars adopted it. But it was actually 85 years from the invention of the seatbelt. And it seems like the reason that the seatbelts were actually adopted is because of this sort of shift in the medical community. And so if you think about Dan Geer's talk again, what he's saying is we need to criticize engineering, right? The criticism by the medical community of the automobile industry is the first step. And the second step was to come up with a prevention method, which is like saying, okay, first you're doing the wrong thing, and then here's how to do the right thing. Simple steps. So what I'm really trying to do today is give you a security criticism of modern big data engineering. And then second, hopefully we can come up with some prevention. What's our seatbelt going to look like? So what's happening today is that we're really moving into this new world where we've found power. We've got so many horses now, we've got this massive engine, and it's taking us faster than ever before. Lots of changes coming ahead. But should we really trust it? Is that environment really going to take us where we need to go? So let's start with some security criticism. All right, first of all, risk management. I find time and time again that people set up the threat model in a big data environment that is totally fictitious. So I find this also actually with chess. You know, so many people talk about chess and Watson. Oh my God, the human is no longer going to be able to beat anybody or anything because computers will take over the world. But what they carefully ignore is that when computers try to play the game Go, they lose consistently. In fact, they say if your mobile phone beats you at chess, that's normal. They're able to get the power of Watson down into these chips now. It's more and more the case that you should lose. But if you play Go on your phone, there is no way you should lose. You should be able to beat your phone every time, which is disappointing because I lose consistently. But I suggest you try it, see if you can win. The idea is that we take these simple models. Chess is like very simple. You follow the rules and you do everything on the board and the computers can figure out the mathematical model. But if we move into a complex or a real or a social world of conflict like guerrilla warfare, then it gets very messy very fast. Anybody know what the M&Ms represent? Brown M&Ms separated from colored ones? So this is a Van Halen story that's sort of funny. He used to put a rider, he'd tell people how to set up his stage and all of this stuff, and it would be so big that he was worried that people wouldn't read the whole thing. So he put in there a little clause that said, make sure that the M&Ms are separated. Then he'd walk into his dressing room and he immediately knew if people had read the whole thing or not, because he could see whether the M&Ms had been separated. And if they weren't, he would assume, well, everything, lights are going to fall down, they're not going to have the right stuff on stage. So it's a way of using gaming, essentially, to understand your opponent and to understand the situation you're in. Right? So check out Go. Look at how the computers are failing and ask yourself why they're so bad at it. So let's look at data integrity. So this is a funny story. I just have to tell it because my brother is basically, I'd like to dedicate this part of the talk to my brother. He's kind of a genius. He doesn't really get out much, but he does a lot of really interesting stuff. So he was studying plasma physics, astrophysics. Radar to him was sort of second nature, how it worked, and he got a speeding ticket. So he shows up at the court and he says, I'll explain to you why this didn't work. Right? Radar has all these flaws. The data is flawed, the way that it was used, the way that it was fired at me, the things it picked up. There are all these good reasons. In fact, my favorite reason is the guy is taking a selfie by accident, pointing the radar gun at the rearview mirror. And so the court said, are you an expert? And he said, no, I'm not an expert. And they said, well, it sounds like you're an expert. So you didn't register as an expert. We have to throw all of this out because we're not prepared to defend ourselves against an expert in court. And so all of the information that was going to be useful was thrown out, and here's this person saying, I will tell you how to improve the system for better integrity, for a better way of catching threats, and they were like, no thank you. We don't have a way to receive that information, but we can give you a bill, and you'll have to pay. And just on that point, I also want to make the note that my brother and I actually were working on this Skyjack. How many people have heard of Skyjack? Yeah, so Sammy released Skyjack, and immediately my brother and I were talking about it, and he found a flaw as soon as it was released. And so I started tweeting about it, and then Sammy picked it up and then he gave me credit because I have a Twitter account. My brother, who runs Incognito, who doesn't even have a Twitter account, didn't get any credit. So I've gotten crap for that since. And so I just wanted to reattribute that to my brother. So it's actually his flaw that was found. But I'll still take credit because I have a Twitter account and that makes me more advanced than him. So when he catches up to the modern age, I'll give him credit fully. But seriously, I got into a similar situation where I was caught by a cop going pretty fast with a laser detector. And I thought, man, if I can fight this in court, I can get off. And then I remembered my brother couldn't get radar thrown out, even though there was overwhelming evidence of integrity errors. So how was I going to defend myself with laser? I researched it and found out that the judges believe laser is so infallible, you cannot argue it. That's basically the sentiment in courts. So I thought about my social science background and I thought, well, maybe it doesn't matter that this is a lying system. Maybe LiDAR really isn't the issue. Maybe there's something else going on. Anybody notice something missing from this diagram, by the way, this image? This is a LiDAR image, actually. It's used, extensively to do 3D modeling of environments. There's no living, moving things in that image, right? So if birds fly through, if planes fly through, it kind of screws up the image. It doesn't really tell you about moving things, it tells you about static things. I ran into this the other day when I was in San Francisco, and there was a LiDAR detector they use it for mines, to map inside of mines and stuff. And I was walking down the street because they're making a movie, and they're like, whoa, 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 you can't walk there. The police almost arrested me because I was going to walk into a LiDAR scene they were trying to do a 3D model of. So it doesn't handle moving stuff well. So I kind of took this to heart, and this is a long time ago, but I basically found the judge, figured out who he was, figured out where he went to law school, found a guy that went to law school with him, found out he had a son who actually worked in the court, paid him $75, and the ticket went away. So back to threat modeling and data integrity, they kind of fit together. But I guess my point now is that we use LiDAR a lot, and the big data systems are just, one way of looking at this. The new Google cars, they have LiDAR detectors on top that are building a 3D model of the world around them. And we just implicitly trust that these Google engineers and these systems are all going to be right and they're going to work well. But it actually comes down to more than technology. It comes down to sometimes a decision about ethics. So for example, if you're in a head-on collision with a school bus, maybe Google will decide to send you off the bridge instead of the school bus to save the children because you're expendable. If you leave that decision in their hands, assuming that the LiDAR detector picked up the accurate information. So if you fool the LiDAR detector, are you actually telling Google to do something in reaction to it? right? So integrity errors are a big issue, and they will become even more of an issue in the future. And just to that point, the Google system seems closed to me, but I've noticed that the military is developing LiDAR systems. So there's actually one now on the market that you can supposedly plug into your Google Glass, even though I don't think the Google one does. And then you could have LiDAR in your car giving you a 3D model that you can see in your Google Glass for zero visibility situations. And if you really want to get into it, it goes back into the 1980s. If you look at the Operation Eagle Claw, the reason that the United States lost the Delta mission in the desert when we tried to rescue hostages is because one of the helicopters had zero visibility, picked a point on the ground, and then started to follow it because he thought it was stationary, and it actually was somebody walking. And then he accidentally rode the helicopter into one of the big planes, the C-130s, and they both exploded. So humans make errors looking at things, thinking that they're real. You put a computer in charge of that decision, and it's not clear that it would make a better decision. All right, so confidentiality is another case. Anybody seen Until the End of the World in 1991? Nobody? God, it's such a good movie. One person. It's kind of an obscure movie, and there aren't many copies of it. I had a hard time. In fact, I have it on VHS. That's how bad it is. So I watch it, fuzzy VHS. But basically, it talks about, you wouldn't believe this, it talks about automated cars with GPS in them. It talks about search engines, right? This guy gets on his computer, and he's a private investigator, and he searches there isn't an internet, but he searches basically the equivalent of the web and the internet in 1991 for that information. So or maybe he used Gopher, but they didn't mention Gopher. So anyway, the point is, it's this crazy futuristic movie that's talking about things that we're dealing with today, and it's all about confidentiality, how someone's trying to escape and they're trying to catch him. But I mention it because it's weird. I noticed in 2014, someone's built this car. That car actually was running. It was like a pilot who built a motorcycle that looks like it's a fuselage, the front of a jet. So he actually was so successful, it's been picked up, and you can buy this now for like $80,000. But it ties in very closely to the Internet of Things and what people are talking about in big data. If you look at the Ford dialogue around the future of automobiles, they're talking about the wearable device that is the vehicle. You essentially get in, strap on, and you can go like RoboCop, super fast and anywhere. And the reason I mention this is because think back to the Google decision about the other threats around you. The decisions you're going to make about red lights are going to be very different. Red lights are really stupid. They really don't know anything about anything. You try to give them a little bit of intelligence, and it really doesn't do you very much good. But if you know that an hour from now you're going to cross paths with a car, and you can slow down a fraction of a second so that you don't even see that car, well, now you're talking about the things we use for air traffic control, right? You even talk about the things we use for networks, right? We use collision avoidance and detection. So if you talk about the future of Internet of Things, this example, right, I pulled some data from GE, for example, that there are 100 physical and 300 virtual sensors per small gas turbine engine. And so if you put each blade in terms of size into the Library of Congress, you find that in 1 month, since they're outputting 500 gigabytes a day, each blade is generating the equivalent of the Library of Congress. And that's just to monitor the engine. So when we start talking about the decisions about threats and the decisions about how we're interacting with each other, you see the massive scale. And some engines have as many as 20,000 sensors. So people talk about the wearables as though they're the future, but for me, really, it's these sensors that are in these engines that are inside environments that are talking to each other that we really need to think about securing and making harder. So big data really generates new relationships. You can see in how threats interact with each other, how we monitor people's behavior. And so you have to ask yourself, who would you trust in that situation? Who has access to it? Who has control of it? And so now we get into more of the meat of the technical presentation. So let's talk about the realities of big data. But I also want to point out that there's something strange about how every time we move into a new technology, there's sort of a group that comes out, the Cloud Security Alliance, for example, or there might be a big data security alliance soon, but they say, we understand this better than you, so we'll come and we'll explain to you how it really works. You can't understand it in your primitive ways, your infrastructure ways. And there's this sort of divide between the people moving forward and the people sort of holding on to the past. And so it reminded me of what I learned when I was a kid about Babar. So a bunch of you have read Babar. I don't know if this is news to you, but it's really from the 1930s, and it's about French colonialism. It's basically saying, this elephant goes to France, learns the new ways, and then comes back and is king because, well, you should leave behind the ignorant ways of Africa and you should adopt the new ways of France because you backward people need to learn from us developed people. The new rulers that you take on must be outsiders who have been influenced by these new ideas. And so you have to be careful when people come into the big data realm that they're not telling you something which is sort of outside and you don't accept it just because it's from the outside. You really should think about preserving some of the past. This is the relativism of anthropology. So the idea is that there's a balance between what we had before and where we're going. And sometimes people overdo it. So let me give you two sides of that equation. People say on the one hand, by 2017, Everybody's going to be up to their eyeballs in big data. It will be the norm for data management. So that's not very far away. And at the same time, the analysts are saying, but we don't have any controls for it. They're embryonic at best. So with those two sides, I say we just sort of apply what we've already known and we find new fits where necessary. So if we look at CIA, for example, confidentiality, integrity, and availability, these are the sorts of issues we've run into in big data environments, so we can try to fix them by creating controls for our CA model, and then of course regulations. With that in mind, it becomes interesting to look at, there are so many models of big data evolving, so you can go from centralized big data that's being pushed out to business units, you can go from little business units that are just doing it themselves, and the central is just watching on the sidelines. Sometimes there's a relationship between the central office and the outside business units, and sometimes you just hire some outside firm and say, you know what, you guys should do this for us. But in all of these cases, what we tend to see is that none are being led by IT. IT is the old horse, and they're looking at this new weight and saying, we'll try to catch up to you. And so the question becomes, how do we catch up? If you break down big data environments, really what you're talking about is a 5-step process, although sometimes I use 6. But in this case, you're looking at bringing data in, putting data into some environment, storage environment, you're analyzing that data, and then you're bringing the data back to look at it so you can make sense of it, and then you make actions upon it. And so if you take these 5 steps and you say, how do we create CIA on top of it, and then how do we govern that, it becomes sort of simple to understand. This is what I've been trying to do in the book, is break it down and say, these are the areas that we need to focus on, and these are the controls we need to create for each. So a simple how-to framework would be, I believe, these 6 steps. Does anybody recognize these 6 steps? Anybody know where these come from? Nobody recognizes these. Hint. Everybody should know these. Does anybody work with credit cards? Protecting credit cards? Yeah, PCI. So this is the PCI 6, right? It's kind of scary that no one recognizes it, but that's life. So I think many people don't read the PCI, they just go through it, like because they have to. But if we apply the PCI, it's not because I really believe the PCI is the best answer, but we have a lot of experience with it, and we know where we failed so far. So we're moving forward, and at least when you look at these 6, it covers a lot of stuff that we know we can use because we've been using it already, and I believe successfully. I've been giving presentations since about 2009 to say how this has been used successfully. So I'd be happy to discuss with anyone. I have the charts to show, I believe, where we're trending and where we can improve. But I don't usually tell people it's the PCI, incidentally. Sometimes I just tell them I have 6 steps for them to do, and they don't mind that. If I tell them it's PCI, they go, oh, I heard that doesn't work, right? So it is sort of a relativistic stance. I do admit, sometimes I just say I have 6 things that are really good for you, and they go with it. It's a matter of trust. So with that in mind, there's progress to consider in other areas. We've seen already in the big data environment, people are applying different models. And so if you look at the store layer and the operation layer and all of the connections you can now do into those, there's a sidebar that comes up all the time, which is security. And you have different options in there for the future, such as Knox, Rhino, Sentry. These are things being developed, and hopefully they'll make progress enough that we can use them. But in the meantime, it doesn't seem to help much. Anybody using Rhino, for example, yet? Anybody installed Sentry? Using Sentry? No. Yeah, that's been my experience as well. It's sort of like good stuff, pie in the sky, but we're not really applying it directly. And some of the experience I've had is because when you really look at how these plans and projects break down, they aren't really offering anything it's tangible. It's not like the PCI DSS where we say, here's an execution plan, go and check to see if these controls have been set. It's more like, I've masked the names, but you have distribution A of Hadoop where they say, make sure you have your ADPV. Distribution B says, make sure you have your PAAE. So what we're really talking about in these environments is, for example, you need to build perimeters. There's no doubt about that. But the distribution that comes to you and says, you're secure if you have a perimeter, is not looking at security properly in my mind. You have to have perimeters, but that shouldn't be a check. How do you build the perimeter should be the check, right? You want access controls, you want monitoring, you want logging. Those are the things to be looking for. And so when you look at the second one, encryption is listed, but again, I don't think that encryption is the way to go. I think data protection with a changing model of what encryption should look like. These are the sorts of things we've learned from regulation. These are mistakes made in the past. And if we really break it down by the AAAs that we used to use, and you look into a big data environment, you find Kerberos and you find tokens. That's good. If you ever see someone say turn on security, what they're really saying is turning on Kerberos, and that's a stronger authentication, and even sometimes encryption. But it doesn't mean that it's actually safe. And authorization really isn't that great because we don't have that many ACLs. And then finally, when you talk about audit, we have very scattered logs throughout the environment. So let me break it down a little bit further. When we dig into authentication, at first we only had one user. The Hadoop environment was literally the Hadoop user. Well, that wasn't very good. People realized right away that they should change it, so they moved to HDFS and MapReduce. That's good. But of course, that's still just 2 users for a lot of power in the environment. And of course, if you're going to do some administrative work in the environment, you essentially have credentials that give you access to all of the clients. Where does this break down? Let's say, for example, you want to do bidirectional certificate authentication. So you put certificates on your clients and you put certificates on your servers. It sounds good. You can set it up, go to all the effort, and you have some different certificates for every client so it can communicate with your server, and the server recognizes them. But think about that for a second. You have a single user that has access to all of those certificates. So it really doesn't matter if somebody can see every other certificate. They can do whatever they want with them, replace them, delete them, update them. So there's no privacy, there's no security of any of the client certificates, which breaks the whole model of doing the bidirectional authentication. You're basically having one person manage the entire environment. So it is actually a lot of hassle to create the individual certificates. Why bother? You have a single user. But even more to the point, if you turn on the security environment, you move from a world where you have sudo -u HDFS, so you're using the user HDFS to run the command Hadoop on the file system, and you're running -RMR. Can anyone tell me what that -RMR means? Recursive, right. So it's remove recursive. It's like it's RM -R in Unix terms. So what you're basically saying that if you have this single user and you say remove all from the top recursively, you delete the entire infrastructure. And we've seen this. We've seen people who are new to Hadoop go in and run a command accidentally. They're single user, they delete everything. But if you add security, now you've added Kerberos, so you're safe, right? Well, how does Kerberos work? Before you run that command, you run a kinit, and then you get your key tab, so it gives you the key tab. And where does the key tab get stored? Can anyone tell me? Gets stored in the temp directory, of course, which is world readable. So you have your tokens put into a directory where you can then use them. Then you just run the command, because now you don't have to sudo, of course. You just say bin Hadoop, and you have the authority to do it because you have your key tab. So these are the sorts of things I've been running into. And as I noticed when I was watching Blade Runner the other day, this is something that's been warned about since quite a while, since the 60s, 1968 technically. But the movie came out, of course, later, but the book originally goes back quite a bit. And this is where the client gets this Kerberos token, and it says, okay, I'm going to be strong authentication, so I'm going to be safe and secure, and I'm going to pass that to my job trackers who are going to do things on my behalf. I'm going to set up an environment where these little robots are going to go off and do bad things that I can't do at a faster rate than I can. They're stronger and they're better. And then they're going to go and get a token, and they're going to be authorized to do this, and then they're going to delegate that token, and then there spawn jobs that are going to take that token, and pretty soon you end up being Blade Runner, where you're chasing these tokens around and trying to kill jobs. And I've actually seen data scientists do this, where they're in the environment, they're looking at other jobs, and they're saying, those don't seem to have the same priority as mine. And they're running for a long time, and I want my jobs to complete, and since I have pretty high level authority, I'll just take them out. So I'll destroy those jobs. So not exactly the best authentication system. Just to dig in a little bit deeper, there's a delegation token exposure I noticed recently where the tokens themselves end up in the URL. So if you're passing URLs to people, you're passing them the delegation token, so they have authentication in their hands. And even worse, the delegation tokens can end up in the logs. So then you just go through the logs and find the tokens. So these are the types of situations we're finding in the environment. At the same time, we're also finding that the passwords and the secrets are stored sometimes in the code or in the environment themselves. So when you dig down into it, you can see there's quite a bit of reality around how to secure an environment. Like if you have a perimeter, it really has to be a perimeter, because if people get inside the environment, they can do a lot of bad things. And we've actually seen a lot of environments go down. People ask me today, have you seen any major breach reports as a result of this? But what tends to happen is the data that's in these environments doesn't tend to be breach worthy. It's not something regulated. It tends to be stuff that hopefully they've cleaned, or they don't believe it to be sensitive. So those are where we've seen the most incidents. In environments where they actually do need to do sensitive data analysis, they tend to split them out and move them into a very separate container. But that defeats the whole purpose of having Hadoop environments. If you want to have a big data lake where you store everything, and then you're breaking stuff out and putting it into a separate container, you're going back to an isolation chamber where it's out of date. You're not doing you're scooping stuff out over and over again. And so the question is, how out of sync is it? How small is it relative to the other stuff? How do I reattach and complete the analysis? But that's how people are dealing with this. So the realities of the big data environment are this. We have data that tends to be shared. We have networks that tend to be wide open. The nodes are distributed. I often find HTTP, rarely HTTPS for a lot of the consoles. Web services are open, access controls are open, and the clients are unauthenticated. So across those 5 areas. So what are we doing about this, right? So what are the solutions to some of these big data environment issues. Well, the first is scoping. And scoping is really important because you've got to figure out what you're going to build your perimeters about. Because that's what we're doing, is we're building better proxies, better perimeters. And I'll show you how. So once you figure out your scope, where you really want to build a perimeter around, then you move your data into a safe spot. So now the inventory and the storage of data is moved into this zone, and essentially all of the compute nodes are talking to that zone over the network. So this gives you the ability, because obviously with perimeters you can check people coming through to see if they have authentication. So once you're I should back up a step there. So I need to mention also that the availability increases because, I don't know if it stands out, but one of the primary problems in Hadoop environments was that the inventory would go down. So in other words, the name node would lose track of where everything was. If you remember when Google, for example, would index everything and you try to go, say, index my site, and then every so often you wouldn't be able to get it to index properly, it's probably because they might have had a name node failure, and so they weren't indexing at that time, they had to rebuild it. And the way they rebuilt it in the old days, this goes back to the Beowulf days, is they would have a checkpoint, and so they'd go back and rebuild it using the checkpoint. It wasn't a fully available, fully redundant system. So this legacy continued until people started to realize, well, we could just build redundant name nodes. And so that's where we're at now. Recently, redundant name nodes have come up, and so now you have essentially an inventory that's spanned across multiple nodes. So if one of them fails, you just switch over to another inventory and you keep running without an outage. So this has been a major advance. So then, once you have availability, you can classify your data, and you can say, okay, this is actually a difficult part to do, but Accumulo, as an example, gives you classification capability to where you can say, this data is more sensitive than this data. And this is a very important step, and if you use it properly, you can set it up for the next step, which is where you can assign authority. So now you can't access the data unless you have the authority to access the data. And if you've properly stored your data in a repository that has the ability to check an access control list, now every time a compute node tries to do something on behalf of somebody, or you try to do it directly, it'll do a lookup and say, you don't have rights to this data. Even better, if you figure out that existing data sets you want to access need to be turned into the Hadoop cluster, you can just turn them on. So you turn on HDFS in an existing environment that already has Active Directory credentials. Now you're talking about accessing data using existing credentials, and you've added controls that we used to use in the old world. So it's the new world and the old world colliding. We're using the things we used to do, and we're doing it at speeds that are actually competitive with these new compute node clusters. So once you have authority, we'd like to move to where we get to least authority. And so this is sort of based on the LAFS model, right? Least authority file system, which is that if you can assign a key and you can have the classification set up properly, now when people try to access data, the access is determined by whether or not they have the key for that data. So if you want to talk about it in terms of columns, if you don't have access to the zip code, you don't get to see the zip code. And we saw a recent release that's open source from Google that did exactly this. It shows you how you can query a data set and you can see some columns, but you can't see other columns because you've encrypted only those columns, and those are the sensitive ones. So we're moving to where we can have authority based on your privilege access, and if it's stored centrally, again, you've created a perimeter, essentially a proxy, where people have to go through in order to get access to that data, as opposed to putting them inside the perimeter and then giving them full access to the data. So let me give you an example of how this works in a healthcare environment. People would want to come into the environment directly, but instead you move them through a services layer. And in the service layer, you essentially are adding the access controls I spoke of, and you're adding some of the monitoring and logging you would need, which is a little enhanced to see what they're doing exactly. In the cloud, we did this to an extreme. We actually had key logging on some nodes. So when people tried to go into a cloud environment to manage it, we would log everything. And that was the way that we could compensate for the fact we didn't actually have logging inside the cloud environments. So we would see everything on the outside and the perimeter proxying in. So we could do the same thing, and we can have policies there as well that said, you're not supposed to be accessing this data set, or you're not supposed to be making that type of query, or you're not supposed to be making any queries. And so this is a way that we can front end the services to the data lake, and then also the resources that make it expandable and make it flexible. So if you take it back a step to the actual healthcare delivery system, then what you have essentially is people coming in through the normal access portals, and they go into the care delivery environment, but now there's a services layer that sits in between that basically fronts all of the stuff that they're trying to do with big data. And so the protection layer is, in a sense, in that proxy. Now, this is not the most ideal situation, I realize, but this is where we're at today. If you want to build security into an environment, you're essentially building perimeters, and the smaller the perimeter, the better. But there's a point at which if you build a Hadoop cluster, you can't build small perimeters because everybody has the same level of access. It gets very difficult very quickly to make it small. So if you want to move this direction, you can at least use existing, already in place access controls. You can use already existing identities. So you can pull those identities. You can use those access controls on the way into the environment, and so you're fronting it. And you still get the benefits of the speed, and you still get the benefits of the access to lots of data in one place. So let's talk about future directions, my favorite part of the presentation. Because this stuff, it's frustrating, honestly, because we can't do a lot of good stuff. You know, it would be better if we could get into some of the, I encourage people to get into the Apache discussions and look at some of the things people are saying. Yesterday, I think, or today even, somebody suggested, for example, we turn down encryption because 256-bit encryption in Java requires an extra step. So 128 would be better because it's faster in terms of setting it up, right? So more people need to be involved from the security community in these discussions to say, well, although there's an extra step involved, making default 128 goes back to why are we using weak defaults, which in the security community we've been saying don't do that over and over again. So let's talk about where we're going. A lot of what I've seen in terms of future directions is based upon the philosophy of servers are not pets. You should treat all of your servers like cows. And I believe this came from CERN out of Switzerland, and it was picked up by people like Netflix and others who started saying, hey, your servers aren't things you should be cuddling and holding and treating so well and like, you know, monolithically working with. You should be just treating them like disposable assets like cows are, where if it gets sick, you just shoot it in the head and it dies and you move on to your next cow. The problem is, I didn't feel like people who said that really understood pets or cows. So they're saying, these are your systems, this is how you manage your environment, which probably is a little bit exaggerated. And then they're saying, oh, this is how big data systems really work. You know, it's just like this mass of cows that we don't even think about. There are just so many, we don't have to keep them healthy. But if you know anything about livestock management, and I recommend people read it if they're curious, because it actually does map quite well. You know, Dan Geer's talking about the CDC, but there's actually quite a bit, in fact, I would say arguably more known about livestock management than there is about dealing with pests in the human community. If you look at rinderpest, for example, the way that we've eliminated rinderpest in Africa is instrumental in understanding how we can get rid of other types of viruses and pests. And so, and the doctors talk about it extensively. What was the key that led them to the solution that eliminated rinderpest in Africa? So with that in mind, I started to think, what if cows are pets? What if what we're really talking about is assets? Pets are an asset because they give you comfort and they give you, I don't know, people like to hang out with them because it's companionship and so forth. And cows are assets because they give you milk, they give you meat, I don't know, they give you, people have reasons that they have assets. They're both assets that people like to have around. But I know I had a pet die. When I went to the vet and said, oh my God, the pet's sick, the vet said, we don't understand really why. Would you like to spend a lot of money to help us understand the pet problem, or do you want to put it to sleep? But I'm sure if I brought a cow into that vet, they would have said, oh, we have a huge amount of data on what's wrong with this cow, and we have a huge amount of systems and solutions that we can help you with. And so really, we're talking about kind of the opposite of what people were saying. And this kind of blew my mind. I was like, wow. The solution really is in taking an asset view and finding a solution that we can use that's inexpensive. It's like the whole commodity model of big data. Can we use a security model that is a commodity model? And is it available somewhere else? And so the answer was yes. I had already given a talk about this in 2012 where I said the cholera example in London in 1854 tells us that if we can use proper math and analyze the data streams, we can figure out where the source of bad things are coming from. And so if the nodes are even marginally intelligent, they might be able to help us identify a source of risk. So the interesting thing about this example that always kills me is people talk about the ghost map, but not many people talk about the white space in the middle of the ghost map. So the ghost map tells you where everybody was dying, but the white space tells you where they weren't dying in the middle of all the death. And it turns out that this was a brewery. So obviously drink lots of beer tonight because that'll make you healthier. You will not catch cholera if you drink beer, is the lesson from that. But actually the lesson is that people were drinking water that was probably sourced from the brewery. So they had their own source of water in the middle of everyone getting bad water. And so this was both the white space and the black space tells you quite a bit. This is how analytics can get quite messy. You can get the wrong conclusion. Beer is not the answer. Having your own source of water is the answer. Anyway, it boils down to systematic treatment is where we get resilience from. And that is why I started to propose this idea that, and it seems to work everywhere, if you can easily identify the problem and you can have a routine treatment for it, and you can use minimum judgment, it tends to go away. And then there's a question of like percentages. So I guess with measles, you need 85% to be successful, and with rinderpest, they needed 90%. So these are like mathematical, biological models that have to do with replication and speed and things. But it's a simple enough formula that we can understand if we can get the treatment in place, then we can make it go away. But how do we come up with the treatment? Well, that's where we use an IKEA model, which has nothing to do with any other IKEAs. It just happens to be coming, I brought this out of livestock management. You identify as quickly as possible the problems, And then you keep adequate records of the problems, you evaluate them daily to understand where they're coming from, and then you just keep adapting until you improve. So it's like you have a big brain that's trying to treat the problem, and then you have the cells that are actually treating it, right? Your brain doesn't have to respond to every scratch in your body. So what if the big data systems, going back to the beginning of the presentation, if you have 30,000 nodes or sensors inside an environment that's basically roped off, nobody gets to go in because they don't have very good security controls, but they can identify amongst each other whether something's going bad, one is misbehaving, and they can report that. This is essentially where we're going with SCADA systems. This is essentially where we're going with big data IoT. This is what you should be looking at. If you have 30,000 nodes and you have one administrator, that administrator needs to be doing IKEA, and then the nodes need to be doing ERM. So this is sort of the future. This is a much better model than what we're doing right now. And so what we need to be figuring out are signs of illness. And so we need to look for example, HTTP services are probably going to lead to some sort of infection. If you have no encryption on the management consoles and multiple people are in there, they can get passwords and they can take over environments and they can pollute the data streams. You can look at these job tickets and see where they end up. For example, someone already figured out that they've ended up in the URLs, they ended up in the logs. You need to get rid of that. That's a sign of sickness sure to come and haunt you. But again, threat modeling, we use really simple threat models. So most discussions I have are with people that say, hey, we're playing chess and we're winning. And I'm thinking, well, as soon as somebody starts playing a more sophisticated game, we're going to lose really badly. So we need to start thinking about how people are going to abuse the data nodes, how they're going to abuse the APIs. And then, of course, with Kerberos, I've noticed there seems to be a lack of standard of randomness. In fact, you don't have to have any randomness at all in a big data environment, and you'd still be Kerberosing, so you'd be secure. So when some vendors say, like, turn on security, they're not telling you what level of randomness, which would shock people in the security community, but in the big data community, it's just like, hey, we turned it on, so it's secure. There's a big disconnect right now between communities and the work we're doing. So that's sort of signs of illness, which means if you had a big data environment, you could look for signs of illness all over. This is a simplified version of a MapReduce setup, but basically you could look for, dead cows. Look for sickness or even dead cows all over your environment. And if you can get the information back to find them, then you can start to take action and understand it better. So it's using models that we've used forever, but applying them into these internal environments and collecting the data in a way that's useful. And I think if you use the ERM IKEA model, at least I've found, it actually helps break up a lot of the debate, because people say, well, that's really dumb, that won't work everywhere. It's not supposed to. That's aspirin, it's supposed to deal with a headache. So I don't want to use aspirin for everything. And people say, well, that's really hard, no one can do that. And you say, well, it's not supposed to be easy. That's a doctor trying to find a solution to a problem. And so it's actually going to be hard, takes a lot of training. So if you leave the two parts separate but allow them to integrate, then you find, I think, the best balance. And so we get back to how to solve the problem of trusted IT, which is to create transparency in these environments to understand really what's going on and how to solve them. And then create relevant tools. So in some cases, we need new tools, definitely need ways to solve problems at scales bigger than ever before. But we also have old tools that we can modify or adapt. If you actually look at airplanes and cars, one of the things I point out is they both have seatbelts. So it's not like you throw out the entire car security model that I presented to you when you go into the air. You actually do carry over some of the basic controls. In fact, when you think about it, they're doing the same thing. So cars are on a suspension, which is really important for performance, so that's a security control, and brakes. Well, airplanes have wings that have suspension built in. So they're both reacting to, you would say, the environment, but they're just doing it in different models. So you're using the same idea, but you're just implementing it differently. And then finally, resilience. Without resilience, I've seen environments where they show great performance at first, you start to scale up, you add in more data, start to use them for more important things, and then they just die. And I've seen like crazy issues around people saying, we might not be able to continue doing Hadoop because our clusters are now dying at such alarming rates. So you really got to build resilience in, because people won't trust Hadoop at all or trust big data environments unless they're truly resilient, so they have high availability. So with that, I'd like to say thank you and open it up to questions. Any questions? Yes. The book should be out in October, depending on how many more flaws I find. The challenge really is that writing about the realities of big data is that I wanted to give people enough to work with. I don't want to just say, hey, it's all broken. But it's being changed while I'm writing it, which is good, so I can say there's progress in these areas, and then I also want to point to areas that need more work. And so it's drawing a line in the sand and saying, this is everything you need to know to build a secure environment. Any other questions? Yes? The question is, am I involved in the work that Pivotal is doing in the area of Hadoop and security? Yes, very involved. So EMC and Pivotal work very closely together. In fact, some of the controls that I spoke about today are solutions you could use in those environments. And not just Pivotal, but EMC works with lots of distributions. And then Pivotal also works with other storage providers. So I'm working within a community. And one of the things I guess I should point out is we don't have good standards yet. So I'm throwing up 6 standards from PCI. I'm talking about IKEA, and these solutions. We don't have a group yet. We're working on that to where people could say this is a baseline of security that all distributions should be looking towards. More collaboration between the distributions. Okay. Yes? So the question is, what's the influence of open source? It's a great question. I've been in open source since the beginning of my career, and there's a love-hate situation there. On the one hand, I find people, especially the largest environments, they tend to, because of the open source, are able to go out and grab stuff and develop on their own, which is awesome. Because then they're solving problems on their own. Our customers are actually finding solutions, and we can partner with them. They can bring stuff to us. We can bring stuff to them. It's all out in the open. On the other hand, there is something to be said, I believe, for people doubling down and creating something that's closed because they're really working on it and they want to create a solution that comes out that's more robust. And the open source community is still behind because it's arguing about other things. Like they're stuck on something and they don't want to move forward in this area. So you can create your own proprietary, move forward in that, and even inform the open source community. So it's a love-hate. Sometimes it works better, sometimes it works worse. The obscurity sometimes actually hides things that are bad, and sometimes it protects things that are good. Yep. We find that with Accumulo, for example. Accumulo was open sourced, and now it's moving very fast. It feels like people are adopting it more, so that's been good. Yeah. Laughs is also open. So, yes. So the question is, does SPSS work with Hadoop? I haven't used SPSS since the 90s. Yeah. So, sorry, I don't know. Is there a preferred analysis tool for Hadoop? No. I mean, it basically depends on the person who wants to do the analysis. There are so many tools in the ecosystem. I didn't put up a slide, but there are literally hundreds of tools you can choose from, and it just depends on what you're trying to accomplish. SPSS we used in social science to do analysis of crime data, and it was just the preferred tool because everyone was using it. I don't keep track of that now. I mean, data scientists would be someone to ask because they have preferences for all sorts of different reasons. Yeah. In fact, I get in trouble because I'm not a data scientist, and the analysis I do, when they look at it, they go, that's not how a graph is supposed to look. You've totally cheated. I'm like, yeah, but I'm convincing somebody of something, so. Any other questions? Yes? So the question is, can you use something other than Kerberos, use other identity solutions, identity management solutions? And the answer is yes. We could talk after, but basically, this is something that comes up every single time I've been to any security meetup. People say, when are we getting rid of Kerberos? And if you look at the origins of it, it was in 2009 when Yahoo said, essentially, we believe Hadoop will be used inside an enterprise environment, and Kerberos is a standard on Active Directory, so we'll integrate with that, because that's just, they kind of tried to see the future, and they made a mistake. And so that was quickly realized because I actually used to work at Yahoo. What we found was, you can't use Kerberos. It doesn't scale. Everybody knew that. And so on the Yahoo front end, when people were checking their mail, we weren't using Kerberos. So Hadoop is shifting to that model, essentially, which is using, what everybody already knows, cookies or tokens, or that's why we have this delegation token problem on the one hand. On the other hand, I'm already seeing lots of movement to LDAP and existing Active Directory stores. So the Kerberos really becomes just a legacy of the original Hadoop design. So you'll integrate with it just where it's necessary for the old components, but as things move forward, they're going to use much more modular identity management systems. In fact, they're building more and more of that. I didn't describe it in too much detail, But the way that they're going to solve the problem with secrets being in the files, for example, is to open up a list of URLs. And so you just have an API that says, where do I go to get my credentials? Those could be LDAP credentials. And then you just, so as more and more components become modular, you'll be able to do that. That's where everything's headed. Already the solutions I'm talking about already are basically integrated into existing identity management. You're not setting up new Kerberos identities. So they're pulling from existing identities so that you can say, do you have the rights to look up this data with existing users? Any other questions? No? Well, thank you then.